Hey guys, so today we're going to go ahead and we're going to do some practice problems on the worksheet that you're doing for homework. I'm going to reference our notebook often, so if you need that or if you have that, take that out. But let's look at this first problem here where we have magnesium and it has a number here that's 12 and a number here that's 24. Now you have a key up here that should help you as well, but we also have our notebook right here that should help us. So it tells us that the lower number is the atomic number and it's the number of protons. So that makes life easy. So here's 12, so that's the atomic number, and then it's also the number of protons. Now our notes also tell us that the upper number right here is the mass number, and it's the protons plus the neutrons. So we can write in our mass number. We have 24, and it told us it was protons plus the neutrons. So we know that if we were to kind of make this into a math problem, we would have 12, our protons, plus our number of neutrons is equal to 24. So in order to solve for this problem, we would take 12 from 24, right? Because we want to get the n all by itself. So I would take minus 12 on this side, minus 12 on this side. We have now n by itself, okay, and that cancels out there. And so we would also get 12. So the number of neutrons is 12. All right, so then it asks us for a charge. Right here, it doesn't show any charge. And we said in our notes from last week that that's basically where we find the charge, in the upper right-hand corner. So it looks like there's no electrical charge. So let's just write none. Last but not least, it's asking us for the number of electrons. Now, if you remember that if there's no electrical charge, and we reference our notes that when protons equal electrons, we have a neutral or no charge. Okay, so that means that our protons have to equal our electrons. So we had 12 protons, that means we have 12 electrons. Now, not all of them are going to be as simple as that. So let's look at one that does have a charge. Why don't we look at the magnesium down here? Now, magnesium, we can look, and you know what? It doesn't have it there for us, but we know from up here that magnesium has an atomic number of 12, because no matter what, the number of protons magnesium has to have to make it magnesium has to be 12. All right, so it still has the same mass number. It's 24. And so if it still has the same mass number, it has the same number of neutrons. So remember how to find that. We take 24 minus 12, and we got 12. Now it asks us what the charge is. So it's a 2 plus charge. All right, so what does that mean? Well, when we reference our notes again, that when we have a positive charge, we have more protons than we have electrons. How many more protons? Well, that's what this number tells us. We have 2 more protons than we have electrons. So all we have to do is take 12 minus 2, because we're figuring out the number of electrons, and that would give us 10. Okay, so if it were opposite, if we had 2 negative, that means we have 2 more electrons than we have protons, and you would add 2 to that 12. You're going to answer 2, 3, and 4 on your own, but let's try out number 5 together. So this is an example from the video. So we have iron 54, so we know it has an atomic mass or a mass number of 54. So let's go ahead and write 54, and we know we find it at a 6% ratio. So remember, when we want to find out our average atomic mass, we have to turn this decimal or this percent into a decimal. So we move the decimal to the left 2 times. So that turns into 0.06. So we take 54 and we multiply it by 0.06. Then we're going to go ahead and we're going to do the same thing to the 92. So we take 56 times, remember, move the decimal 2 places to the left, 1, 2, 0.92. All right, well then let's look over here at the last one. Oh, and we're not timesing this. We're actually adding. So we would add those numbers after we do that. So then we add 57 times, remember, move our decimal 2 places to the left, 1, 2, times 0.02. To solve this then, you multiply all of these together and then you add them up. Your number should be really close to 56. Okay, so I'm going to have you do that on your own. So your number should be really close to 56 because we find it at such a high percentage. Okay, so of all the different types of isotopes of iron, we find iron 56 at the highest percentage. So our average atomic mass should be around 56. Let's do one more together. And that's going to be question number 8. So it tells us an element exists in 4 different isotopes. So we're going to do the same thing that we just did. So it looks like we have a mass of 49.9461. And we find it at 4.35%. So again, I'm going to take it times point, I move the decimal twice to the left, 0.435. And I would find what that was. Then I'm going to add what the other one is. So then it tells us 83.79 has a mass of 51.9405. So 51.9405 times 0.8379. Then we add the next one. We have 52.9407. So 52.9407 times 0.095. And our last one, we have, 53.938 times, it looks like 0.0236. All right, so you're going to go ahead and you're going to multiply all of those, and then you're going to add them together to find the average atomic mass. Now this one, what is the identity of the element? What you're going to need to do is you're going to need to pull up a periodic table. So if I go into Chrome and I search periodic table of elements, okay, we want to make sure we find one that has enough information. So periodic table that has the atomic here, this one looks good. This one has the atomic mass. So I'm going to pull this up. Let's open image. Maybe I have to put it here. Open image in a new tab, and let's look at these numbers. Okay, so the number that's right here, okay, do you see all these right here? That is the atomic mass. So can you match the atomic mass that you just found, okay, from multiplying these and then adding them together and finding the average atomic mass? Can you match that with what's on the periodic table? So guys, that is it for the help. You should be able to, by now, figure out the rest of these, and the both front and back are due tomorrow. Hope you have a nice day.